I would like to thank the Young Planners Committee, Jesslyn, Joel, Desmond, Jessica, and Vanessa for arranging this, and Bong for helping me so much with the setup. Thank you very much. Okay. Good evening, everyone. Once again, I'm Ong Si Hai. Sometimes I write my name as Si Hai Ong because I do a lot of work overseas, and I find it amusing when people say they cannot find Mr. Hai. Okay, I've done master planning work in over 20 countries, work in the public as well as private sector, in urban planning, infrastructure, software, and business consulting. But my passion now is to work with a younger generation, like all of you here, to use digital planning tools to transform our urban and industrial places for an increasingly complex future. Let's start. As we all know, the typical master planning process includes some form of information collection, site and data analysis, and then we design some preliminary plans and we evaluate the various alternatives. We produce visualization graphics for insertion into PowerPoint and into master plan reports. So nowadays, we use a variety of software to do this. This could be in-house map systems and applications. Google Earth, I think we all depend on it a lot nowadays. And of course, the usual helpful software, Photoshop, SketchUp, and AutoCAD as well. In future, we hope to accomplish most of these tasks with just QGIS. We can still use SketchUp, Photoshop, etc. But for most essential work, QGIS should be very useful and very fast to help us. QGIS is a free open source software which you can download from the website here. It is developed and maintained by a very large and active community of volunteers across the world. As you can see, there are more than 40 million users. To me, this is simply amazing. Before we go on, I would like to say something about master planning. Here, I'm referring to a development project-oriented approach, focusing on developing a new town, an industrial park, or it could be a tourist resort. Now, private master developers are common in many countries. Recently, I visited Batam. Yes, Batam, 40 minutes by ferry from here, and was very impressed with a master development with factories, residential area, and even a kind of a nature reserve. In Singapore, HDB and JTC are the two largest master developers. The master developer may build all the apartments and factories, or they could subdivide land and sell to second-tier developers. Usually, this is a very profitable business. Now, older government-prepared city plans are heavy on the development project-oriented approach, or what we have called the master planning approach. For example, the 1958 Singapore Master Plan, which identified comprehensive development areas to accommodate population growth. And here we can see the diagonal hatch. This is actually a new town zone. And this vertical hatch here is Nanyang University in the early 1950s. The 1958 Master Plan is an important milestone in Singapore's planning history. It was initially led by a gentleman called George Pepler. Okay? And George Pepler had earlier been responsible for introducing the 1947 English Town and Country Planning Act. Today, right, we are familiar with the need for planning permission, development charge, and many regulations. Now, all this can be traced back to the 1958 Master Plan. Since the 1960s, government-led urban plans throughout the world have shifted more towards policies, content, and also involve greater citizen participation. In many countries, government do not build more public housing, but rather focus on tweaking policies to incentivize the private sector to include more affordable housing in their residential development. Plan names have changed accordingly. Instead of master plans, we have structure plans. In fact, the KL urban plan is called the KL structure plan, which was named after a type of plan that was common in England in the 1970s. And in fact, our concept plan is based on a structure plan, just to make it more confusing. Other names for master plans that are popular nowadays include development plans, framework plans, and so forth. More policy discussions are now included in the Singapore Master Plan, even though the name has not changed. So unlike other countries, we still call ours the Singapore Master Plan. The master planning approach, however, is still relevant, especially at the neighborhood scale, as we can see in this example from New York City, where they want to redevelop the rail yards for new residential and commercial development. Okay, now I come to planning methodology. Patrick Geddes, some of you may know, he is one of the founding father of modern urban planning. His survey, then analysis, then plan approach can still be traced in most work we do today. In the early part of the 20th century, Patrick Geddes said, before we cut up the patient, we need to diagnose what is wrong with the patient. Hence, the Singapore Master Plan in the 1950s started with a diagnostic survey, looking at the condition of buildings, the number of people living in slums, and so on. So the purpose was to analyze and find out what was wrong. Now, survey analysis plan evolved over the years into a rational planning approach. Instead of one plan, several alternatives are now generated, and these are then evaluated before the preferred option is further refined as the final master plan. This is well and good, but over the years, planners have learned that there are severe limitations with the rational approach. In the real world, where there is messy politics, conflicting interests, and the uncertainties of future forecasts, do we have maximum aviation or maximum commercial industrial development? Who decides? Politicians, citizens, or the planners? These are very difficult questions. Design thinking. This is an approach from product engineering that has become very popular for many fields, including even some planners. In design thinking, it starts by empathizing and defining the problems, then generating ideas, and then a prototype. The final design evolves from the learning gained along the way. Now, actually, it is not much different from the rational planning approach, and it has the same old limitation and problems. Okay, but one major contribution from design thinking is wicked problem, which accurately describes many urban issues such as homelessness. One solution can well create another unintended problem. So urban problems are very messy, and urban plans, the chance of fixing everything is actually very small. The role of master planning in a project feasibility context is actually easier to understand. So first, a market study is carried out to determine whether there is demand for the envisaged development. This could be a residential district, or it could be a JTC, a new kind of a flatted factory. Okay? The market study will look at what the competitions will be supplying into the market in the next few years. And the market study will also recommend type, scale, and the phasing of development. Then next, the role of the master plan is to lay out the desired facilities, the infrastructure, and we'll also look at the social and environmental impacts on the surrounding areas. How can we reduce these impacts? And things like regulatory compliance. Okay. And then the third part, the financial analysis, is the most important. If this project is not financially feasible, it will not go ahead. So to do the financial analysis, we need revenue streams. This can be estimated from the market study and the land supply that is envisaged in the development phasing of the master plan. And of course, the infrastructure cost is usually the major component. So from the master plan, we are able to deduce what would be the infrastructure cost, make some estimates, and this is then fed into the financial analysis. In the urban planning process, planners contribute more as facilitators rather than experts in many situations with complex issues. Now, in Singapore and a few countries, such as China, this is an expert panel meeting that I attended. Experts play a much greater role. Like private developers, government-linked corporations like JTC typically work with experts to develop urban and industrial land and facilities. Unlike a policy approach where you have to open it up to a much wider circle of citizen participation. The rational approach still provides a useful basis for planning work, but planners must be aware of the many problems and limitations inherent in this approach. Computer tools can help us to speed up and sharpen our work, but are by no means the replacement for the planner. Finally, we come back to what QGIS can do. First and foremost, QGIS can help us overlay maps from multiple sources. These sources may be in-house, provided by a client, or could be publicly available sources that the planner should take the initiative to explore. Now, in the past, we don't have this wide availability of public data, especially public map and plan data. But today, there's such an explosion of this kind of data that the availability of fast and affordable drone survey is one of the greatest things that ever happened in recent years. High-resolution terrain models can be created, visualized, and analyzed with GIS in a matter of days. The old generation of planners simply did not have this possibility. I couldn't do this until maybe the last 5 years. An area image and a digital elevation file. These are actually TIFF files, TIF. So it's something like JPEG, which is produced by through the drone survey. We feed it into QGIS, and then there's a QGIS tool which straight away creates the terrain in 3D and allow us to view it. Elevation model, the DEM. QGIS has some tools which automatically generates contours for us. So this, which used to be a big problem in the past, is no more a problem. Even if for some reason, we can't get the drone survey going, there are satellite digital terrain model that's publicly available from the websites of the United States Geological Survey, as well as from companies such as Japan Space Systems. There are some drones today that can fire LiDAR, which is actually a kind of a light onto the ground. And based on the different time that is taken for the signal to bounce back, right? So this measurement is recorded. And based on that, the software is able to automatically point cloud 3D model. You can go to this website. They have a coverage of the entire world. Now, on the right side is a project I did, okay, and all the data has been fed into QGIS. QGIS has this function which allows you to export the model into JavaScript, okay? And because it's JavaScript, you can send this data to any of your client, and all your client needs is a web browser. Here I use Firefox. You can use Microsoft Edge. You can use Google Chrome. 2014 master plan. This kind of data is available from a government website called data.gov.sg. Okay. Here we have it in SHP format. SHP is quite a common format for GIS data, and you can just drop SHP format data into QGIS and it will display. Okay. And then in QGIS, you have to do a few things. Number one is you have to set the coordinate reference system. So in Singapore, our national coordinate reference system is SVY21. We open up a database manager, which is built into QGIS. And in this database manager, you can load a query file. This file is called landuse.sql. Now, I wrote this small little file. Everyone can use it. And you can use it repeatedly for every single file that you drop in. What this SQL file does is that it will query whatever data you have downloaded for some land use to calculate the land area, okay, for every land use zone, and then it will sum it up and produce a summary table. Let's say in QGIS window here, right, we modified one of the zone. This zone, instead of being a commercial zone, right, I think it's business park, I change it to residential. Okay. Every time you do some change here, you save your change, you come back to this database window, using the same code, you just click execute again, and then the numbers will all be updated. And QGIS is wonderful for automatic map production. Inside QGIS, there's a thing called a layout tool. Once you open the layout, right, whatever is in your main windows appears in this layout. And then you tell the system, you want to add stuff to this layout here. So what do you want to add? You want to add a legend. So pop, comes up this legend. This is automatically created, okay, by the way. It goes into the data, find all the different zones, and then it creates everything, okay? And then you say you want to have a scale bar. It automatically creates a scale bar. You want to have a attribute table. Attribute table, that means all the data table, which we have created one, which has all the numbers of the total area for each type of land use zones. So all this is added onto your map. And then you can move things around, you can scale it around nicely. And once it's done, right, you can straight away print this out or save it as a PDF or as a JPEG, and you can paste it into your PowerPoint or paste it into your Word document and so forth. There is a built-in map in world map in QGIS. Okay, then we go and find some UN data on carbon emission from the UN website, and this is downloaded as an Excel file. Then we use the database function. We create a SQL. We join these two together. Then we say how we want to classify them. So here I made some attempt. I say 2 to 500 high, 5 to 2000 very high, and the rest the highest. And you can play around with it. Maybe instead of 3 categories, you can have 5, or you can say from 2 to 400, 4 to 6, and so forth. So we say we classify it like that, right? Then we say, how about we change the classification such that only those above 5,000 are in the highest category. So instead of 1,000, I change it to 5,000. So by changing the categorization, we realize that only one country now, the rest are in the middle group. So we can play around the classification. And earlier on, I told you QGIS has a built-in world map. So the way to access this world map is to come to the bottom here, type in the word world into the coordinates box. Okay, yeah, the world map pops up. On the emission map, you can play around changing the color ramps. Okay, next I want to talk about generative design. Okay, imagine if I were able to tell the computer, okay, please help me automatically generate all possible layouts satisfying these conditions. Then I give it all the conditions. And not only that, show me the 3 best layouts in terms of lowest earthworks cost, road gradients less than 4%, and so forth and so forth. Now, unfortunately, this is not possible yet, but the day will come. Okay? But definitely, there's a huge demand for this kind of capability. I did this project for industrial project on a slightly hilly area. The earthworks cost is 40%, and I did about 20 rounds of this. From the first round to the last round, the cost dropped from 23 million to 12 million. So it's worth generating a lot of different designs and then keep exploring it. Plot here, the rule is you need to have minimum 1 access. And if the plot is a big one, you need to have minimum access from 2 different roads. And the roads cannot be steeper than 4% or 3%, whatever you specify. So in this case, it was 1 into 25. So this is 1 into 25 is 4%, I think. Yeah, 4%. So then the program will run through, all right, and then we'll check that all those things that doesn't comply, it will reduce the gradient or it will reduce the elevation of the proposed platform. So after a while, everything will reach an equilibrium, then you have a perfect solution. Okay? But this is just one layout, and then you do the same for many other layouts. Okay. So if we don't have the computer, we just use a hand-drawn kind of alternatives. We'll never be able to achieve such a large amount of alternatives. Of course, the other thing I have to tell you, right, to reach this level will take many years, even for young planners. Okay. For old planners, it will take a generation. It took me a generation, 30 years to reach this. For you guys, because you're young and you're smart, a few years, you will be able to reach this level. Example here, another example, right? So we already have the drone survey. So we are able to have a 3D terrain model. Next is we ask QGIS, tell me the watersheds. Now that's very important and very effective. So straight away it calculates the top of all the hills and say, okay, this area is one watershed. Okay. The blue lines are the watershed, the top of it, all right? So this is one watershed area, then the other one is the other one. So then we know that, okay, the rivers will be flowing down this side, whereas from here, the river flows to the other side. And then on the right side, we have another example. This is done by somebody else. I just pulled it from the web. Basically, what they try to do is to work out the hospital catchment, okay, the catchment around a hospital. So I guess all these are hospitals. And then the area served by the primary hospital is given in different colors. So this requires some kind of network analysis. Another project I did, the whole purpose of this is that we need to have super fast visualization. I did it in maybe 20 minutes just using QGIS. It doesn't look as good, but it communicates all the key plans, the key ideas, which is what the client wants. And based on that, the client is able to say, okay, move this around, move that around. How about this? How about that? So we can do really quick visualization using extruded buildings and trees in QGIS. And for this project, I had to draw the outline of the buildings and all that. Actually, I didn't really draw it. I just tell the program, I said, just set back 50 meters from the plot line and assume that it's a building line or something like that. Okay, what shall we do to learn QGIS? There are a few levels of learning. Basics, you need to really learn these basics to be able to get the hang of the software. And you can do it in a day. In one day, you'll be able to get into QGIS and do quite a few things. Maybe 1-2 months of use. Then you are very comfortable in everything that's listed here under basics. This includes the user interface, how to import data. Because I told you today, the planners are not just taking data from a very narrow set of information given by the client. There's a whole big world out there of publicly available data. And you need a fast way to go and import this to supplement what you have. You need to be able to query the data. Just summarize for me, what is the land use total, okay? And one of the important thing in GIS is a coordinate reference system. Okay, I don't want to talk too much about this, but this is something that stumps a lot of planners. Because the Earth is actually a ball, right? But we want to make it flat. So the way we do it is called it's called transformation. We transform it into small little flat pieces, each one with a 0, 0 somewhere. So they all have a different coordinate reference system. Okay. Georeferencing is when someone gives you a JPEG or TIFF or whatever, okay, and you need to match this correctly with the actual location as they appear in Google Earth or Google Maps. Okay. This process is called georeferencing. It means dragging it and scaling it until it fits into all the other plans. Symbology, QGIS can do wonders. It can change colors, it can draw curved lines, okay? It can put labels. Labels is like road names. Layouts, I already told you, you can use it to put in your report. Attribute data, which is all the text data. Okay? And one of the very important tools I recommend you to learn is actually not a core part of QGIS, but I find that it's super useful for planners. It's called QGIS 3JS. Okay, this is the 3D modeling part of it. And you can actually learn to use it quickly. But the problem is you need to generate the data. So for now, you can only view data, but to generate your own 3D data will take some time. And of course, the database manager, which is very important. Okay. Then once you master that, level 2, okay, You can do a bit of drawing, editing. You can do what is called topology checker. And there are some other important tools like buffer, give me a 500-meter buffer around here. And raster tools. So raster tools are like for instance, I said that we have this digital terrain model, right? The digital terrain model, you can use it to do earthwork calculations that engineers use to do, and by just playing around the pixels, you can do all this kind of thing and also create watersheds and so forth. All right. Level 3. So we keep going up the levels, right? Level 3, you learn some. SQL is a structured query language which is used to query a lot of database. Okay, and people get paid $10,000 to do data analytics. SQL is one of the most fundamental tools in data analytics. It's a very old tool, but it's still widely in use today. It can be very simple to learn because it looks like English, and it can also be very complex. You can do really complex things. And then at the level 4 thing, you've mastered everything that QGIS can give you already. So you go into Python, and then you use Python and to display all your other things in QGIS. Okay. Level 1, I said a couple of weeks. Level 2, maybe 2 months. Level 3, maybe 2 years. Level 4, maybe 4 years. You can go to all this website. The official training manual is very detailed. You can use it. Okay, you can attend courses, there are Coursera, Udemy, and so forth. And if sometimes you have a quick question, you just go to this website called gis.stackexchange.com, or you just type in Google or ChatGPT. They will give you more or less the same thing. Now, one of the challenges is that there is a lack of learning material providing a quick, broad QGIS learning for master planners. Many of these resources go very deep into small things, but it will make you very bored after a while. As a beginner, what you need is a quick but shallow grasp of most important functionalities that are relevant for your work. So the learning strategy is you can look through all these videos, documents, but skip through all the irrelevant sections. Okay, bravely do that. Don't worry. Okay, and that way you will find your learning more interesting and faster. Okay, how much time do we have? Actually, we are running out of time. Okay, I think I'm going to stop here. The rest of it you can read. So basically all that's what I want to talk about today. I want to reserve the last 10 minutes for discussion. So please go ahead and say something. Thank you.
Hi, hi. This is Desmond here.
Yeah, hi Desmond.
Actually, thanks to all the participants who have signed up. I think this is a very wonderful sharing, of at least an overview of how QGIS is applicable to planners. I personally have not really used it in depth, but just some questions. You talk about this tool. It's really a quick overview. You can get a quick sensing of the data of the particular site that we're doing, right? So the question is that in the course of doing that, does it also have features like you can create a very quick kind of a dashboard? Because often we have for example, if you're doing a planning, there are a few parcel of land, we want to see certain performance data or some sort, of the site. So does it allow us to do that so that we can have a quick presentation to the clients?
Yes, but it's best you control it, because if you want to write automated program, it's harder. You have to go to at least level 3 of your learning.
All right.
Yeah, but if you just want to control it by yourself, you can do it once you reach level 2.
I see.
Yeah.
So hopefully all of us will take some time to go through and the training.
Yeah. Okay, actually, I'm surprised that so few of you all use it. And I have one message for you. Better get onto it real fast, because I think you all are too slow already. Okay, the world is changing so rapidly. I think we're all stuck with the old kind of planning. Okay, today is only an overview. Maybe in a few weeks' time, I'd like to start with a first session of hands-on walkthrough. So I will go through some of the very simple things. So my plan is like that. I will go through 1 or 2 sessions of hands-on. Okay, but after that, you have to learn yourself. And then maybe 6 months later, I will go to level 2. Then level 2, I will also do some hand holding at level 2. Then you go and learn yourself. And then that's how we pull each other out by the.
Sounds great, CI.
Yeah, okay.
I think what we will do is that at the end of this lecture, we'll share a survey form. So do let us know what do you think about the the content of this, and whether you're interested, about future run of this similar course. And we'll share it with CI.
Thank you very
Thank you,
much.
CI. Thank you, CI. Thank you, everyone, for attending the session, and thank you for sharing the other applications of QGIS also, not just to urban planning, architecture, but in other sectors. We'll follow up by sending everyone a link to share their feedback. And yeah, we look forward to seeing everyone again in another session. It would be good if we can just react also, so that we see whether you have any other opinions, surprised, happy, or whatever to this session. Thank you, everyone, for attending.
Thank you.
Thank you, everyone. Just a quick one before we leave. Quick photo. Thank you.
Yes. Okay.
All
Done.
good, Bong. Thank you.
Thank you.
Good night, everyone.
Thank you.
Thank you,
Thank you very
CI.
much.
Thank you, everyone.
Thank you.
Good
Good
night,
night.
everyone.
Good night.